10,000 turkeys. One weekend. One mistake, and millions of dollars worth of food could be ruined before a single guest takes a bite. Imagine standing inside a massive festival kitchen before sunrise.
Toss the chilies now.
Forklifts are moving pallets. Steam is pouring from industrial cookers.
Balance.
Hundreds of workers race between towering stainless steel machines. And somewhere in this controlled chaos, a countdown has already begun.
Basting sequence
Because in
initiated.
just a few hours, thousands of hungry visitors will arrive expecting perfectly cooked food. Not dry. Not undercooked. Not overcooked. Perfect.
I think the rosemary
The
was
question
a good
is,
choice.
how do you cook 10,000 turkeys at the exact same time without creating the world's largest culinary disaster?
The mathematical
The answer
architecture
isn't
of
cooking.
infinity repeated.
It's engineering. And hidden behind the scenes of America's largest food festivals lies a world of industrial physics, thermal science, and logistical precision so sophisticated it looks more like a NASA operation than a barbecue.
Are stabilizing.
Most people think cooking a
Cross-reference with
turkey
the
is
fluid
difficult.
dynamic simulation.
Maybe you've hosted Thanksgiving. Maybe you've worried about timing, temperature, or keeping the meat juicy.
Achieved.
Now multiply that challenge by 10,000. Suddenly, the familiar kitchen problem transforms into a mathematical nightmare. Because at this scale, every tiny mistake becomes catastrophic. If even 5% of the birds dry out, hundreds of turkeys become unusable. If temperatures fluctuate too much, entire batches can fail. If cooking schedules drift by even a small margin, thousands of meals
Quality
can be
control
delayed.
check initiated.
This is where
on
the story
line 4.
begins. Long before the first turkey enters an oven, engineers are already solving problems most people never realize exist. The first challenge is surprisingly simple.
Right in.
Heat does not behave the way most people think it does.
System.
In a home oven,
on it.
a turkey
Rerouting
sits
coolant now.
alone. In a festival operation, thousands of birds occupy enormous cooking chambers simultaneously.
We need that salmon plated
Suddenly,
now.
every turkey becomes part of a giant thermal ecosystem.
on the garnish.
Heat moves between surfaces.
The feast
Air currents collide. Moisture levels change.
culinary neglect.
Temperatures rise unevenly. And that's where disaster starts. Because heat is never perfectly distributed. Left uncontrolled, some birds would cook faster than others. Some sections would dry out. Others would remain undercooked. What appears from the outside to be a giant oven is actually a highly complex fluid dynamics problem. This is why massive food operations rely on engineering solutions that most home cooks have never heard of.
Golden harvest of
One of the
flavor,
most important
ready
weapons
for
is
the
steam.
feast.
Critical on line 4.
Not ordinary
Closing
kitchen
the valve
steam.
now.
Industrial steam.
We have a containment breach.
Steam
on second
carries
gen.
enormous amounts of thermal energy. Unlike dry heat, it transfers energy rapidly and evenly. It penetrates spaces air struggles to reach. More importantly, it helps preserve moisture inside the meat itself.
The apex.
Imagine thousands of
Rerouting
turkeys
the thermal
entering a
current
giant
now.
cooking
Check the
chamber.
particle vortex.
Instead of relying solely on hot air, engineers flood the environment with carefully controlled steam. Every droplet becomes a tiny energy carrier, transferring heat efficiently throughout the chamber. Temperatures become more uniform. Cooking becomes more predictable. But even steam isn't enough. Because another enemy is waiting. Time. The longer a turkey cooks, the greater the risk of moisture loss.
Perfection. Slow
And moisture
roasted
loss is the
and
silent
ready
killer
for
of
your
large-scale
feast.
food production.
Failure of thermal
A dry
distribution.
turkey isn't simply
The intense
disappointing.
heat has rendered
It's
this
evidence
section
that the
of
entire
carbonized
thermal
fluid.
system has failed. To
Containment
prevent
failure
this,
imminent.
festival operations
All
often
personnel
employ a
must
process
proceed
that
to the
sounds
nearest
almost
blast.
unbelievable. Before cooking even begins, vast quantities of brine may be injected into the birds. Thousands upon thousands of gallons. Salt. Water. Specialized flavor compounds.
Adjusting the
Each
regulators
injection
now.
serves a
Stand
critical
by for
purpose.
stabilization.
Most people think brining is about flavor. At this scale, it's about physics. Salt alters how muscle proteins interact with water. It helps retain moisture during heating. It changes the internal chemistry of the
Trying to
meat
bypass
itself.
the manifold, it's stuck.
In simple terms, the turkey becomes better equipped to survive the brutal thermal assault waiting inside industrial cookers.
On an
And this is where the engineering becomes fascinating.
Temperatures are rising on
Because
sector
every
4.
turkey represents stored water.
Speed up the prep on table 12.
Every turkey releases moisture.
To the Apex
Every
Gastronomy
turkey
Division.
changes the environment around it.
All product is standardized
As thousands
for
cook
optimal
simultaneously, humidity levels inside the cooking chamber continuously shift. Too little moisture. The meat dries out.
We are
Too
clear
much
for
moisture.
launch. Enjoy the
Texture
festival,
suffers.
everyone.
The margin for error becomes surprisingly small. Engineers monitor airflow patterns, humidity levels, and thermal gradients with incredible precision. Some facilities even model airflow using computational techniques similar to those used in aerospace design.
heat distribution.
Think about that for a moment.
Spiking again on the main
The
valve.
same principles
I know,
used
but
to
we can't
analyze
slow down the line,
airflow over
just monitor
aircraft
it
wings
closely.
can be applied to cooking dinner.
The lamb, 2 steaks
And they
on the
have to
pass.
be.
Yes, chef.
Because when 10,000 turkeys are involved, guessing isn't an option. Then comes perhaps the most extraordinary piece of the puzzle. Synchronization. Most people assume cooking large quantities simply means using larger ovens. The reality is much more complicated. Imagine thousands of turkeys entering a system at different times. Some begin cooking earlier. Others later. The resulting chaos would be impossible to manage. Instead, entire operations are designed around